Dear students, myself Dr. Avinash K, Assistant Professor, Department of Chemistry, ATM College of Engineering, Mysore. So today we are going to see the experimentation of determination of iron in the TMT bar solution. So this comes under the VTU first year syllabus, that is Applied Chemistry, lab for all streams. So as you all know, TMT means thermomechanically treated bars. So these bars are nowadays very important engineering material, and it almost contains iron and carbon. So to make it as a solution, a known weight of TMT bar will be dissolved in concentrated HCl solution, and it will be collected in a standard flask, and it will be made up to a mark of around 1 liter and will be used for determination of iron. In this experiment, potassium ferricyanide produces an intense deep blue color with ferrous ions due to the formation of ferriferrocyanide complex. So this will be used as the external indicator. So the reason is, once the indicator is added to the mixture, it forms a dark blue solution, and further the endpoint cannot be identified. Hence this indicator will be used as an external indicator solution. As we proceed along with the experiment, we are going to see how this external indicator works. So this is the reaction, what happens during the experimentation part. The iron oxide which is present in the TMT bar, when it is dissolved in HCl, gets converted to ferric chloride solution. So this ferric chloride solution will be treated with a slight amount of HCl and stannous chloride solution, so that all the FeCl3 will be reduced to FeCl2, that is ferrous ion. So the solution change from yellow to colorless indicates the conversion of Fe3 plus to Fe2 plus. Now this SnCl4 which is present in the reaction, SnCl2 which we have added in the excess, might interfere in the reaction. To avoid this, we are going to add mercurous chloride. Mercurous chloride converts stannous chloride into stannic chloride, and itself gets converted into He2Cl2, which is silky white precipitate. Hence the stannous chloride does not involve in the reaction. Further, the formed ferrous ions will be titrated against the chromic acid solution, where the chromic acid solution converts the Fe2 plus to Fe3 plus. That is the oxidation of Fe2 plus to Fe3 plus. During this reaction, the indicator what we use here is potassium ferricyanide. This potassium ferricyanide, which is colorless in nature or a slight green color solution, when it comes in contact with Fe2 plus ion, only when it comes in contact with Fe2 plus ion, they form a complex of ferroferricyanide complex, which is a deep blue color complex. So this will be the indicator for our reaction. So before beginning of the experiment, we have to prepare the standard solution of dichromate. Here we are going to weigh around 0.6 grams of potassium dichromate, and is transferred into a 100 cm cube of volumetric flask. The crystals are dissolved using distilled water and made up to the mark. By using the following formula, we are going to calculate the normality of the potassium dichromate what we have taken. So weight of potassium dichromate into 10 divided by the equivalent weight of potassium dichromate gives the normality of the solution. It gives the normality of the solution. Coming to the experimental part. So here this is the TMT bar solution what we have prepared. So this is the TMT bar solution what we have prepared. It has been prepared by dissolving the known weight of TMT in a concentrated HCl solution, and the solution has been transferred to 1 liter bottle, and it is made up to 1 liter. To this we need HCl, we need stannous chloride to convert all Fe3 plus to Fe2 plus, and then to avoid interference of SnCl2 we are going to add mercurous chloride here, and finally this will be the potassium ferricyanide indicator. So this is the potassium ferricyanide indicator what we are having. And the class wise, like we need two burettes here, one for addition of stannous chloride, the other for the addition of potassium dichromate. We need a standard flask to make the standard solution of dichromate. Here already I have weighed around 0.6 grams of dichromate and transferred into the standard flask. Just we have to make up the volume. So now we are going to make up the volume by adding distilled water. The crystals are made up to the solution by adding distilled water. It is made up to the mark exactly towards the 100 ml solution. So our standard solution is ready, and it is the graduated cylinder. We need the pipette. So by starting the experiment, first we have to pipette out around 25 cm cube of the TMT solution what we have prepared here, which contains iron in the form of ferric chloride. So it will be transferred into a clean conical flask. To this we have to add around 10 cm cube of HCl, 10 cm cube of HCl, around 10 cm cube of HCl, and after adding this, the solution has to be placed for heating. To this, we have to add the stannous chloride dropwise. So the stannous chloride has to be taken in the burette. Once the stannous chloride has been taken in the burette and is ready, now we have to take the mixture for heating. The mixture has to be placed on the hot plate for boiling. So once the reaction mixture starts boiling, so take out the reaction mixture. And under the hot condition itself, we have to add the stannous chloride solution until the color changes from yellow to colorless. This ensures that all the Fe3 plus ion which is present in the solution will be now converted into Fe2 plus. Means stannous chloride is reducing the ferric ions to ferrous ions. Once the solution become colorless, now the flask must be completely cooled. The flask must be thoroughly cooled under tap water before adding mercurous chloride. So care has to be taken that while adding mercurous chloride, the solution should not be hot. If in such case, mercurous chloride will be converted into dark black precipitate. After cooling the mixture, we have to add the mercurous chloride. Here we are going to fill the burette with the standard solution of dichromate first, and we are going to keep it ready for the titration. So dichromate has been filled in the burette. Make the mark to 0. So consider the upper meniscus since it is a colored solution. Now place it back on the holder. To the reaction mixture, now add, since the mixture is in cooled, add around 10 cm cube of the mercurous chloride solution. This mercurous chloride solution avoids the interference of the stannous chloride, excess of stannous chloride present in the mixture. So this can be ensured by the addition of, by the formation of silky white precipitate. The silky white precipitate indicates that all the stannous chloride has been avoided. Now start the titration. Before starting the titration, we have to add some amount of water to dilute the mixture, as we are going to remove the sample from the conical flask to the external indicator. We have to add excess of this thing. Now we have already placed the indicator, the external indicator, on the holder. So this is a holder for us. So on this we have placed the drops of potassium ferricyanide indicator. Note down the initial reading. At the first point you have to add 10 cm cube of the mixture. Add 10 cm cube of the potassium dichromate. run down 10 cm cube. Once 10 cm cube has been run down, stop the titration and transfer a drop of our mixture using a glass rod onto the indicator solution. A drop of indicator what has been placed here. Observe the color. So since still it is dark blue in color, so repeat the experiment by adding another 2 cm cube. Continue the titration by adding another 2 cm cube. Now again place a drop of the solution onto the indicator. So here you can observe a slight change in the intensity of the indicator. That means that we are almost nearer to the end point. Now on you can add a increment of 0.5 cm cube. It's near the end point, and after the addition of every 0.5 cm cube, place the drop of the solution onto the indicator solution. Again the solution has become much more lighter. This indicates that we are almost at the end point of the reaction. So now when we are adding the next drop, still it is blue in color. Add some more ml of 0.5 or 0.2 ml of the dichromate solution. So now you are seeing that there is no change in the indicator color. It ensures that the reaction has been completed. So note down the endpoint of the reaction. Note down the endpoint of the reaction. Approximately it has consumed around 16.9 cm cube of the potassium dichromate. So once you get the volume of dichromate that has been consumed, by using the calculation, we can identify the amount of iron present in the ore. So weight of TMT bar in 1 liter of given solution, let us consider this as dash gram. So the weight what we have taken, okay. So we know that 1000 cm cube of 1 normal potassium dichromate can consume 55.85 grams of iron. That means V cm cube of Z normal potassium dichromate can consume 55.85 into the volume of dichromate that has been consumed into Z, that is the normality of dichromate, divided by 1000. So this will be for 25 cm cube. Then later on calculate it for 1000 cm cube of solution just by multiplying by 40. So the percentage of iron in hematite ore can be calculated by the value obtained into 100 divided by the weight of the sample taken. We are going to get the percentage of iron present in the hematite ore. So thank you for watching the video.